So you've also been dealing with buoyancy, and if you remember that buoyancy is the the fact that if you displace a certain amount of fluid, the force that is going to hold that displaced object up is going to be equal to the weight of the fluid that you displace. And you can use that to do some pretty interesting things. For example, if we had talked about being able to measure the density of something or measure the volume of something by dipping it into water and seeing how much it's displaced, but you can also measure the density of a liquid by taking something of known density and displacing it and see what happens. So let's look at problem 67, which from the back of your chapter. And what we have here is we have a chunk of iron, and we're going to dip it into an unknown fluid. So we don't know what this fluid's density is. It's unknown. And we're going to hang this weight of iron, pure iron, in there. And we know that the density of iron from our table is 7.86 times 10 to the 3 kilograms per cubic meter. And this iron by itself has a mass of, so the mass of the iron is 390 kilograms, or 390 grams. That's when it's not submerged, so that's right here. When it's submerged, though, the force that you're measuring, the kind of apparent mass that we have when it's submerged, is 350.5 grams. So that's like if you were to put a scale on here, a little spring scale. When you have it submerged, you're measuring 350.5. So the the buoyant force is supporting some of the weight of this thing. We can write that buoyant force down. We can say that the buoyant force is going to be the difference in mass from the original iron to the submerged iron times G. And so that's due to the density of the fluid that's being displaced. So we can write that down as the density of the fluid times G times the volume of the fluid displaced. And that volume is just the volume of the iron. So volume of iron. So since we know the mass of the iron and the density of the iron, we can figure out the volume of the iron. Since we know the density of the iron is equal to the mass divided by its volume, we can figure out the volume of the iron by just taking the mass of the iron divided by the density, which we know both of those things. Okay, so I'm going to go ahead and plug that in, and I'm going to get that the density of the fluid divided by the density of iron times G times the mass of the iron. So now we have something that I can set equal to this up here and solve for the density of the fluid. So I get the density of the fluid divided by the density of the iron times G times the mass of the iron is equal to the difference in mass times G. The G's are going to cancel, and I'm going to wind up with the density of the fluid is equal to Mi minus Ms over Mi times the density of iron. Now if you look at this is going to be a number that's less than 1, so we're going to get something that's less dense than iron, which is pretty good. And that's going to turn out to be, let's see, this will be 39.5 divided by 390, okay, which is the same as saying 3.95 times 10 to the 1 divided by 390, 3.9 times 10 to the 2, all times the density of iron right there. And we're going to just let those cancel out there, and we're going to get 10 to the minus 1 times density of iron. And if you look at that, that's going to turn out to be about 800 kilograms per cubic meter. And if we look at our table, if you do the numbers correctly, you actually wind up getting 806, and 806 is alcohol. So we can use this to measure the density of the fluid, of some unknown fluid, which is pretty handy.